Hi, Dr. Mendoza. Welcome.
Hello. Yeah, sorry about that. I've always just used a link and then it just kind of threw me off. I had to log into my Zoom, et cetera, et cetera. So
Oh, thank you. Okay, well, thank you everyone for joining us for our sustainability lecture series talk today. We're really excited to have Dr. Mendoza joining us today. As some of you are familiar, in our building, Dr. Mendoza has one of his indoor AQI monitors. So we're really excited to hear more about the work he's been doing, how it's relevant to our jobs here at the library, and also, again, the excellent research that he's been participating in. I'll go ahead, Dr. Mendoza, and just read a quick bio for you, just so folks kind of have a better understanding of kind of the work he does and how it is connected to the university, and again, to what we see here at Health Sciences. So Dr. Daniel Mendoza holds joint appointments as a research assistant professor in the Department of Atmospheric Sciences, and adjunct assistant professor in the Pulmonary Division in the School of Medicine, and the Department of City and Metropolitan Planning, all at the University of Utah. His research interests include quantifying and characterizing urban greenhouse gas and criteria pollutant emissions for use in human exposure estimation and metropolitan planning. He also examines the health effects associated with acute and chronic pollutant exposure, particularly in vulnerable populations. He is the co-director of the Consortium for Dark Sky Studies, serves as editor-in-chief for the Journal of Dark Sky Studies, and is the director for the Dark Sky Studies minor and instructor of the Capstone Class on Dark Sky Studies at the University of Utah. Again, I mentioned some of the work that he does and how it intersects with our library. So please, as you have questions, hold them till the end, and we'll get a chance to kind of dissect that with Dr. Mendoza. But if you want to go ahead, we're ready to hear from you.
great. Well, thanks for the introduction and apologies about this technology mishaps here, but I'm excited to present to you, especially because I've had this partnership with the library for a little bit over 2 years now. And so by the way, just quick show of hands. How many of you participated at the Wallace Stegner Symposium? Did any of you go to it that took place in March at the law school? Okay, great. So the slides are going to be new to you. I've recycled about 50% of them, but all right, here we go. Let me see if you can see what you see my screen?
Yeah.
Perfect. Okay. So this is a collaboration, and I'm going to show the full list of collaborators and funders at the end, but this is the main team that we're working with here in atmospheric sciences and also geography as well. This is a picture took place in 23. It's actually what we colloquially always called it the Canadian wildfires, if you remember, in May of 23. Now, I had the misfortune, if you can recognize this intersection right here, this is just the bike path over by Wasatch Boulevard. So I was actually riding my bike and then the wildfire started to come in. I didn't want to miss the opportunity to take a really awesome picture, but then I hurried back because I know what wildfire smoke does to me and to really everyone. This picture is not doctored at all. You can really see the haze as it's coming in. So, all right, let me start moving forward. So, one of the things that I always want to make very clear when I talk about air pollution and concentrations, etc., is that we've got two pieces. One is the emission, so what is coming out, and that is what we can actually regulate. So that's what the EPA has done. Clean Air Act, any kind of regulations on, for example, the exhaust of your cars when you get your cars inspected, etc. So that is the emissions portion. But then once the wind takes the pollution, it's kind of out of our control. However, for health purposes, that's what's important. So this is where we really do both parts. We look at emission quantification, and then we also look at then what happens to that pollution. How does it move? Where does it get to? Because ultimately, that's what we care about in terms of health purposes, because we want to really take a look at what populations get affected. lots of health effects. I don't really need to go through them. I'm sure you're all pretty familiar with them, primarily cardiopulmonary as well as oncological impact. So this is a picture during our inversions. So this one was it was actually in January of 2019. This is from one of the papers that I cite later on. And this is from the Bonneville Shoreline Trail. So what I really liked about having my office in the Winthrop building, it's right next door to you all, is that all I had to do was cross a parking lot and then go for a run at Bonneville Shoreline. Um, this is one of those runs, and then I looked over, and I mean, you can basically see the downtown skyline. You can obviously recognize that it was 2019 because the number of buildings has probably tripled by now. We can see the smokestack right there from the power plant and then we can really not see very much of the west side of Salt Lake City, which I'll come back to in a minute. This is another event, and I'll tell you why we're going through them sequentially. But this is a dust event. This took place in 2020. Oh, sorry, 2017. And you can really see how we start to get this event, and this happens relatively often and more often now as the Great Salt Lake is starting to dry up. It's from the WB building where atmospheric sciences is housed. So it's basically a view from my lab. And then you can see how very quickly by around almost 11 in the morning, you can't really see downtown. Unfortunately, I always preface these things by saying that Utah has now really become, primarily Salt Lake and the Wasatch Front have now become a true four-season location, right? Because we all know about inversions, and I think many of you might know about ozone season during the summer, but now we have wildfire season as well as dust event season. So we do have a fair amount of what we call exceedances and events that are what we call exceptional events. Something I'd like to talk about in terms of air quality, because often people don't think about it, but temperature and extreme heat is also part of air quality. I mean, ultimately, it is the air that is warm, and that is what really causes a lot of substantial negative health impacts. So this was just from this last year. And as we can see, unfortunately, we are having a growing population of unhoused individuals. And in a very pragmatic way, and I know that I'm not sure a lot of people like to think about it this way, but no matter how cold it gets, you can always bundle up some more. You can seek shelter, add extra blankets, add extra coats, and you might be okay. When it's very hot, there's no way to cool off unless you have mechanical ventilation, i.e., air conditioning. Some coolers as well. And so this is something where we really need to be thinking about when someone is outside and it gets really cold, the code blue situations that we see sometimes in the winter, and they have no other recourse. They could potentially just bundle up more, bundle up more, bundle up more, and they might survive the night, and it might not be it is going to be a health hazard, of course, but it can get but it's something that can be still taken care of. Imagine everyone who climbs Everest, for example. Those people generally just need to just bundle up some more. However, when it gets very hot, especially at night, and if you remember the summer days, which we're now heading to, the air becomes very still when it doesn't have the energy of the sun, for example, then winds die down. And because of that, then you have no other way of cooling off, especially if you're on house. So that's something to really think about because I think many people overlook that and are more focused on the pollutants such as PM 2.5, ozone, etc. So the research goals are to provide reliable real-time air quality and temperature data, create an accessible data repository, identify potential high-risk areas, support health research, inform policy decisions, develop forecast models, and really, I look at four target audiences. The first one are the stakeholders, decision makers. So this leadership, these are the people that could potentially make some decisions, and I will discuss a few of them in later on in the presentation. There's also the general public. I mean, some of the work that we're doing is really to help people, to help inform people. Would you want to, if you really have to go for a run or for a bike ride or just be outside, and we are in a poorer quality event, is there a difference between doing your outdoor activities at Liberty Park, at Pioneer Park? So that's for the general public. We also want to provide information to community leaders, potentially really the groups that represent communities and they can be considered also advocacy groups. So these are the groups that are directly working with community members. It could be religious leaders, it could be nonprofit organization leaders that work directly with communities. For example, also organizations such as the Wellness Bus, any group that really works directly with communities, particularly underserved communities. And then the last audience is other researchers and scientists, health practitioners, etc., who would be able to use this data. And I'll talk a little bit more about the data that we have here in this next slide. So we may all be very familiar with Hawthorne. So when we look at air quality, and if you look at the app, for example, and you're in Salt Lake County, it will likely read the Hawthorne station. That is one of the most famous stations here, quality stations here. It's run by the Division of Air Quality. And that generally just gives either it does have a forecast as well, and it gives you the real-time data with a lag of up to an hour, because data comes in every hour and gets reported every hour. So it's right here. However, it's truly not very representative of the rest of the county. You can see it's pretty much in the northeast part of the county. So the Utah Division of Air Quality added a few others, which are these yellow circles. And then the University of Utah also has additional stationary sites, which are this red diamonds in other parts of the county as well, to try to fill in some of these gaps. Now, this from a paper from 2019, so the network has expanded a little bit. But what I wanted to show was an effort that was started by a colleague, Dr. Logan Mitchell. He was working at atmospheric sciences as well. He's now working at Utah Clean Energy. And he had the idea because as atmospheric scientists, we want to measure through unique ways. And one of the ways that we use that we use to measure on a wider extent is using mobile platforms. Typical is a van or an airplane. And unfortunately, the van misses something, which is repeatability. We can't always guarantee that the van's going to be at the same spot at the same time. Of course, someone needs to drive the van, and there's, the liability, etc. But Logan actually thought about the idea that, well, we have moving platforms that don't, and here's the other key part, they have to be non-emitting, because you don't want something. For example, people have often asked me, well, why don't you do this project here with the sensors in the front runner? The problem is the front runner emits a fair amount of pollution, and so it would actually mask the signal. Instead, we put air quality sensors on 3 tracks lines, on the red, the green, and the blue. And that really started in at the end of 2014. Really, the beginning of the data started to really come in the beginning of 2015. Now you can see how it covers much more. And as we say, the driver is free, essentially. So the next step then was to say, well, what are we seeing now that we didn't see before? There's sometimes a controversial topic, fireworks, but they do have quite the effect on air quality. Now, this is 2019 again. This is this 8 p.m. as you can see. We had trains running on the green and the red line. And this is really the last year that Salt Lake City had fireworks. Salt Lake County still has fireworks, but Salt Lake City has switched over first to a laser light show, and now it's moved to drone shows. It's 4th of July. 9 had a few excited individuals around here. It's probably private fireworks that we might have measured. But again, by the way, this corresponds to what we know as the AQI, the air quality index, the different colors of air pollution. So the green, yellow, red, etc., orange. But now you can really see the fireworks lighting up. This is 10, is when all the fireworks start to take place. And you can see this one right here, that yellow circle, that's Jordan Park. So that's International Peace Gardens. Essentially, that's where the fireworks were moved originally. They were in Sugar House Park, but then they got moved to the west side. Then all of these other communities, if we've got Mary, West Valley, West Jordan. They all have their own fireworks. You can see some in Sandy, Draper area as well. And then something unique starts to happen. So it's midnight. We still have a high concentration here. It's really one of the lowest points in the valley. So that's where pollutants start to accumulate. But something else, right? You see that this part here of the county, the northwest part of the county, didn't really have any fireworks, but it seems that uh, the farther west you go, the worse the air quality gets. And that is, if you've ever been hiking and it becomes nighttime, this is mainly in the summer, really. It also happens in the winter, but you don't notice it as much. But in the summer, if you're hiking and then the sun is just setting, so say around 8, 9 p.m., around this time of year, and you're kind of at the mouth of a canyon, you will feel cold air coming down. That's the downwind canyon flow. So what's happening is we have downwind canyon flows coming from Emigration Canyon, Red Butte Canyon, and so all of that is coming from there. We don't really have canyons on the west side. So what's happening is all of this cold air is coming in, rushing through the canyons, and then pushing all the pollution towards the western part of the county. So then the next step was to, well, the as you saw, the tracks has its fixed lines, but then we really wanted to get into more into the neighborhood scale because again, the tracks goes primarily on industrial corridors, busier parts, whereas the buses really can get to residential areas. And so October 21 was when we started putting air quality sensors on top of electric buses. Again, we needed to wait until UTA had electric buses so that we could put the sensors there and measure pollution from the buses. You can see there are two routes that are more heavily trafficked. This is the number 2 route, which goes up to the university, up to the hospital, goes to the bus garage, the central garage. And then this is the 509, which is the only bus route that leaves from the central garage area and goes all the way to West Valley. You can also see that it's a little bit heavily loaded towards the northern part of the county, and that is because only at that point does the central garage had the charging infrastructure. Uh, Fairly soon, there's going to be so there's the next garage, which is at Meadowbrook, which is right next to the county jail, so 900 west, around 39, 4100 south. That is going to start having electrical infrastructure for buses. So then we'll be able to cover the southern part of the county because that's where those buses depart. Now this is an image from a paper. I like to always just cite the paper so you can see if you have more and if you like more information, you can see the reference. So this stopped in June 2024. It hasn't stopped. This is where the image stops. We have now 15 electric buses. And as you can see, we first started with 3. We started adding one at a time. Roughly every couple of months, 2 to 3 months, we were able to purchase more equipment to put on the buses. So like I said, we now have 15. And we can see increasing. These are the total daily observations of PM 2.5. It's getting to a point where we're reading about 200,000 observations a day. The reason is we collect data every 2 seconds. And then when we average it by hour and day of week, you can see that during the week, we have much more service because the buses are actually running. During the weekend on Saturday, we reduce service to about 50%. So UTA has less routes that are being covered, less buses out and about, and then Sunday reduces further. So we have less data available then. So I'd like to show you when we combine both of them, when we combine the buses and the trains, we get a really powerful network, which I'll show in a minute. But I'd like to just highlight one event, which was this wildfire event that took place September 11th, 24. We had the worst air quality index in the whole world, according to IQ Air. There was a combination of 4 wildfires, and I was actually in person at the Utah State Fair. So fun anecdote, John Fogerty was playing that night, so I was definitely not gonna miss that. But right as he starts singing Bad Moon Rising, the moon was actually coming up, but because of the pollution, it was actually red. The moon is actually red. And I have a picture, it's very grainy. Unfortunately, I don't have a really great camera on my phone. But I'm still looking through the internet to see if I can find a picture of that because the moon was completely red. We had the worst air quality for about 7 hours, from around 6, 7 p.m. to the following morning. So this is how the day started. This is the night before, as you can see, from 10 p.m. to midnight of September 11th. We had a few stations here. There's not a lot of service. There's not a lot of buses or tracks, because tracks really kind of ends around 1 in the morning, and the buses end around 11 at night. So not a lot of activity there. So we jumped out to 4 in the morning. Blue, by the way, is much cleaner air than green. We just wanted to demonstrate the pretty much a cleanest air quality. So this is why you see blue, but the rest matches the AQI. So not really a lot happening. And again, this is particulate matter, which really is not much of a problem during the warmer months of the year. It's really, particulate matter is generally more elevated during the winter time. But now we can see that we're moving from that green, sorry, from that blue, we're starting to get to some green areas. And here you can see some sensors are starting to touch on the yellow. I was actually in a 2-hour meeting, very much a coincidence, at the same spot where the dust event video clip was filmed. So that's from my building atmospheric sciences, and I actually saw the plume starting to come in. So I physically arrived there at 10, and we ended I think at 12:30, and you could see the air quality visibly get worse, because by 4 everything is essentially either yellow, orange or red between 4 and 6 p.m. And then unfortunately we didn't have enough buses going through and enough trains going through, but from 10 to midnight, the entire valley here was red. And this right around here by the Alpine area is actually getting close to maroon, which is substantially worse. That is, I think that's what really the combination of that and what we're reading here in Salt Lake at the Hawthorne site was probably what tipped us into the worst air quality in the world. It was basically up to 3 times worse than red air quality. What we consider red air quality is about 55 micrograms per cubic meter. It was touching 145, 150, which is extremely dangerous to breathe. And then the next day clears out between 4 and 6 in the morning. The next day it's all green and blue. So it's a very quick event, and we have now the tools that can help us identify these events and quantify them. So I'm going to go back to temperature for a minute. And this is a heat watch campaign that was powered by Kappa. And this was very interestingly, it was in July of 2023. I think it's July 15th. I can't remember, it was a Saturday, but I remember that the following day was the hottest day on record, where we actually hit 107 degrees Fahrenheit. So this was really close to that. And it's very clear which areas are hotspots. So this was the way this map was developed was there's a team of 30 volunteers that in the morning, in the afternoon there, the 3 to 4, and then in the evening, which is I think 8 to 9 or 7 to 9, sorry, they either rode their bikes or drove their cars with thermometers, just very high quality thermometers, and they perform routes across Salt Lake City. It's just a Salt Lake City effort. And you can see some hot spots here on the west side, here by where this is where the quarries are, the gravel pits essentially here on Beck Street, and some hot spots as well in the southern part of and then the downtown area as well. You can see where places like Liberty Park, they are much less hot, and again there is a substantial uh, cooling effect that is provided by large amounts of vegetation, so such as parks. It depends on what the vegetation is for things such as golf courses, but the vegetation in general tends to cool the area surrounding it. So the work that we're really focusing on is developing safe environments for all. So the first thing that we do is we look at environmental exposures, either observations such as what I've shown you, or modeling efforts, to then look at health impacts. And one thing that I've learned is, so I originally started working on greenhouse gases. That was my PhD work, looking at CO2 emissions from the on-road transportation sector, so cars essentially. And then I quickly realized that about 50% of people believe in climate change, but 100% believe in lung cancer, which is why I shifted towards health. But as I was trying to really cause some change and really try to make sure that the research developed into policy, I then realized that 150% of people believe in the value of the dollar. So if we tie in economic impacts, then that's going to give us a better shot. I'll give you an example there as to how that worked. And then the economic impacts then drove public policy, which then led to urban plannings. Urban planning is sort of my catch-all term for any kind of change, structural change, or other change within a community, which then led us to be able to model then. So once there were some designs made, then we remodeled, well, what will be the changes afforded by these modifications. So that's where it all stood up until the late winter of 2020, and we all know what happened in March of 2020, which then really highlighted that there were differences in exposure, differences in health outcomes. It really highlighted different sides of society. And so then we really started to look at a fairness and justice side to make sure that communities that were potentially the most affected, most vulnerable, would be afforded information specific help really that's more catered towards what their needs are. So when I was wrapping up my pulmonary fellowship in 2020, I really wanted to look at how can we drive change, because I don't really like to do research that doesn't lead to something actionable, because otherwise we're just, especially this line of work, is just doom and gloom, right? I mean, we can measure everything, but ultimately, what can we do with it? I think we've known, first of all, anecdotally for, I would say, decades, that, for example, the west side of Salt Lake City is faces more air quality challenges. And then with different measurement efforts in the past decade or so, including the work that we're doing, we've been able to quantify that. But then I always have the question that I think is very important, which was asked by my PhD advisor, is so what? So what are you going to do about it? Is it just going to be something that you publish, you do some statistics, and then you hope some people read it? So we didn't want to just stop there. So we wanted to say, well, what is the economic cost? So what we looked at was that what happens when you have a poor quality event, in this case, an inversion, how many school children are suddenly absent the next day? Now, we're not saying it's necessarily just because of the pollution, but it's associated with, because it followed anywhere between 1 to 5 days following a poor quality event. So we looked at the number of absences across the Salt Lake City School District, the 34 schools that we studied, and we saw that there are three impacted groups. So when a child is absent from school, what are the impacted groups? So schools, their budget and again, this is a 2020 number, so really it was a 2019 set of numbers. Schools are allocated around $40 a day per student, so that money is essentially not used to educate students, so that money in a sense is wasted. Families, the average wage at that point was $23 an hour. Now, if a child is all of a sudden absent, generally one parent at least, sometimes both, they take work off. And so roughly that family loses $200 worth of income. At that point, 56% of students in Salt Lake City School District depend on free and reduced meals, lowballed it for sure to $5 a day. Now, first of all, right now, those numbers are closer to 75% of students that depend on free and reduced meals. And it's really closer to $10, but let's just say that that's what the family now has to spend to feed the child that would otherwise be fed at the school. And then lastly, is the economic multiplier, which I've presented probably about 40 times since I published this study. And so far, only one person out of all the audiences knew what the economic multiplier was. So I'll just describe it. I'm going to assume no one knows what it is. But that is what and again, there's a low number. I like to just come up with the floor numbers, because we can just say, well, at the very least, this is the cost. It's probably worse or higher. So the economic multiplier says that for every dollar, at least this factor, for every dollar that a person directly receives in income, $2.50 flow through the greater economy. I'll give you an example. let's say you talk to a contractor because you need some work done in your home, and your contractor quotes you $10,000. That doesn't mean the contractor's going to make $10,000. That means that that's how much you're going to be charged. The contractor is probably going to be making about $4,000. That's what the contractor is going to take home. The rest is probably going to go into materials, taxes, transportation, etc. It's just going to flow. The rest, the other 6,000 are just going to be flowing through the environment some way. So what this means is that when that family is not earning that $200, that means that there's probably closer to another another $300 that are not going to be moving through the environment. And simply it's because that person was doing a job and now that job's not going to be made, which means that other people can't really avail of that economic benefit of that person's employment. So when we put all those numbers together, turns out that the estimated impact just from the Salt Lake City School District, the absence cost within the 1 year of that we studied, which was I think it was 2017, was $452,000 a year. That was a cost. So I approached Representative Mark Wheatley, and together we worked on HB 344 in 2019. And what that did was, as you all know, all schools have EpiPens for emergencies. We said we really need asthma inhalers at all schools, and that bill that we passed now provided emergency asthma inhalers. Utah became the 14th state in the country to have emergency asthma inhalers at every single school. So now kids who, for example, go out to recess and they get an asthma attack, instead of having to go home or instead of having to go to a hospital, if they have the parental permission, then they can be provided an emergency asthma inhaler, which is basically Ventolin, albuterol. And some of them might actually be able to finish out the day, because it's generally the kids who have more challenges, socioeconomic challenges, health challenges, who would then be much more affected by poorer quality. So this is really a success story where we really just came up with what is going to be the cost. And again, this is just for Salt Lake City School District. So within Salt Lake County, there are 5 school districts, as you probably know, Murray, Jordan, etc., and as well as Salt Lake, Canyon. And so what we really want to make sure is that, and Granite, sorry, what we wanted to make sure, this is just Salt Lake City School District. What about the rest of Utah? So this is going to be showing, hopefully in a few years, what the power is of having kids stay in school. So we've been talking about poor quality outside. Ultimately, and I think this is really leading, I know you're probably all anxiously waiting to hear from me about what I found in your own building, but I want to kind of lead to it. These are the air filters for my own house. Now you can see that well, we've got the clean filters on top and then the dirty filters on the bottom. During an inversion period, so this is during the winter, takes about 2 months. I need to change these filters every 2 months because that's how bad they get. Now I live in a specific location close to campus where I did find the downwind canyon flows from Red Butte. So I actually live in one of the cleanest parts of the city. Additionally, I've gone to great lengths to improve my indoor air quality. I have asthma, so it's very important to me. I have both a high efficiency filter in my furnace. I have treated my windows. I have vented my stove. I have an electric stove which is vented outside. Many times when people turn on their stove fan, it's just basically the microwave sucking up the smoke, etc., and then it just brings it back up to the ceiling. But I've actually vented and created a vent that goes outside. In addition to that, I don't smoke. I don't have any candles, incense, any of those things. And pets are groomed essentially daily to get rid of dander. So I've gone through great lengths, but still, this is what I get. Now, this is a very efficient purifier. So I have purifiers that are strategically located to clean the air, and they are hyper HEPA. Many people are probably very interested in having HEPA filters or HEPA purifiers is a hyper HEPA. But it concerns me that despite all the things that I've done, despite living where I live, this is what I get. So we need to be thinking about, first of all, communities that may not know about air quality, who may just, for example, just not even use their range hood, and who may be living in much more contaminated areas because whatever is there in these filters would have otherwise got into my lungs. So this is what we need to really be cognizant of when we're looking at indoor spaces. So what are some potential solutions? So collaboration with the Salt County Health Department is one of the stakeholders that I work with. We put air quality sensors at the Northwest Rec and Senior Center. So it's by the Fair Parks right there. This is the reason why is because it is a cooling center, and cooling centers have generally been considered. So the official name is cool zones, but it's a cooling center, which is a place for temperature refuge, for example, right? This is where people can go when it gets very hot. If you have no air conditioning, you go there. But this is a project that is, and it's a program that's been run by the Salt County Health Department. And I think what we wanted to do is really try to put a little more oomph into it, and really not consider it just as a place to cool off, but also a place to protect oneself from poor quality. And so this is why we place sensors there, and we measured ozone, PM 2.5. And so this is a protectiveness. So this is the summer 2022. We ran it for about a year and a half. We had a sensor on the roof, which is important because we need an outside sensor. And then there's the old sensor. There's a sensor in the old part of the building and a new part of the building. So you can see how, of course, the sensors are doing their job. The cooling center is doing its job, keeping the temperature much cooler than what would be outside, which you can see at the roof. But then what's interesting, it also protects against high levels of ozone. So ozone is not coming into the building as much. You can see that it tops out a little bit above 20, but then during the peak periods, it's above 60. So the reality is only about 30% of the ozone outside is reflected inside. And then if we look at the winter, PM 2.5, we can see that it blocks the majority of the PM 2.5. Now, again, these are very low values because one thing I always like to stress is even though we think about, and I've provided sufficient evidence here, I hope that we have air quality challenges. These are episodic, short-lived, but very high intensity. So, but the majority of the time we have relatively clean air. So our problem when we look at air quality is not an annual average, which is very low, but it's just an episodic, very high intense event. So this is an example of what happened during an inversion, and you can see the inversion build up. By the way, inversions, I think you all probably know, they don't just magically happen one day to the next. They build up, which is why when there are all these campaigns that say it's a red air quality day, consider carpooling, I kind of shake my head a little bit and say, damage is done. When we had the event, when there was what we called the persistent cold air pool, which is when a high pressure pocket of air just sits on top of our valley and then restricts the airflow, that's when the inversion truly starts. It's right here, 30th and 31st of January. That's when it started. That's when we really should be doing a lot to reduce the pollution. So then that way it maybe doesn't get to the red air quality. It's really here early on because this pollutant that was released in the 30th or 31st is still lingering around here. And what's worse is inversions. The problem now that what we call the soup essentially is stagnant, then gases, things that are not particles, they can actually react with each other and create more particles. Those are called the secondary pollutants. They're not directly emitted. Directly emitted are primary. Secondary pollutants are what are formed under specific conditions. So really you get a lot more bang for your buck if you start to reduce emissions earlier on, so then hopefully you don't ever get to the red air quality. But again, same rec center. And then we can see how the roof readings were up here, but then inside we got a little bit less. It actually was very protective. And then here's when we probably had a storm event and then it washed it all out. And then we went back to having relatively good air quality, which is really the norm. Wildfire events are the exact opposite. They come fast and furious, and then sometimes they linger around for a couple of days. But again, you see some protectiveness. Now, one thing that I want to stress is that you can see that much more comes in. Why? Two reasons. The first is wildfire particles tend to be much smaller. And the reason for that is we don't really have a lot of local wildfires that are as large in magnitude or really impact as the wildfires from the West Coast. So now imagine a particle coming in from, say, California, Oregon, Washington State. If it's traveling all the way and it gets to here and it had to go over the Sierras and it had to go over other mountain ranges, it better be really small. So because it's small, then it can really get through filters. The second part is that also some of the PM 2.5, as I mentioned during the winter, are secondary particles, which means that they were formed and they're happy in that colder, the outside air, which is more humid. So because of that, what is happening is we're able to, those particles are then when they get brought into a building where it's drier and where it's warmer, it's essentially changing the environment. So now the particles are unstable. And then lastly, I just wanted to show this, which is PM 2.5 and temperature, as well as ozone and temperature. This is what we really think of as this term, which we call the triple threat. We have obviously higher temperatures during the summer. Ozone is elevated, but at the same time, when you have an episode, and this is an episodic event, the wildfire, then you have all three of them are elevated. We're really looking now at the compounded effect of both high temperature as well as multi-pollutant on health outcomes. So let's get to something that you're probably really curious about, which is this building. So this is your building. And these are the ozone levels. So we started this in 2022. So we've done this in December. So we've really done all of 23, all of 24, and then the first 3 months or so of 25. Again, you do see some of the warmer temperature ozone. It still makes its way in, but by and large, ozone levels, people should start to get concerned when it gets into the 70s. Ozone, as you saw, doesn't really get inside buildings, so it's actually this is fairly common, and your building is very well protective. It protects its occupants against high levels of ozone. So next is PM 2.5. So I'm gonna ask the audience if anyone is brave enough to tell me why I put this shape here on top of this. Does anyone have any questions, any ideas as to why I did that? You can shout it out.
Because our air's too bad in our building.
Yeah, construction.
Yeah.
You're very close. Yes, Sean on the chat said construction because look at what happens during your construction. Red air quality is 50.
Oh,
Maroon air quality, which is what we colloquially may be thinking of as cities such as Delhi and Beijing, is right here, 150. You're reaching levels for prolonged periods of time, or you're beyond that. This is really, really bad. This is inside. This is the sensor that's on top of your vending machine. Oh, by the way, some of you might be curious as to what this is. The very first point here, the very first line that goes to 200. Olivia, if you remember when I was first installing the sensor, the vending machine was really, really dirty. So the sensor was actually just literally measuring the dirt that was on top of the vending machine until we wiped it down. So that's the first point.
whoops.
The rest is your elevator shaft construction primarily. So you're basically, if you kind of eyeball this a little bit, so we go here, I now reduce the scale to 100. You're pretty much in red air quality from December, right around here, December of 2023, all the way through December of 24. With substantial spikes. So this is something I think that I wanted to discuss how we can do this. How we can discuss with facilities, etc., because this was substantial concern when we started to look at these numbers. So this, sir, the results of your building, and trust me, the outside air quality was never like this. This is 100% what your building construction was, because if you see in the back, there's a wildfire, by the way. So I'm just I don't know if you can see my cursor, but in 23, 0707. So that was July 7th of 23. That was a wildfire. So yeah, some of it got in, but I mean, we're looking at 20 over here, almost 30 inside your building. And you can see some of these are going off the scales, especially right around June. I think that because I guess maybe there are less students because of the summer, there's much more intense construction in June and July of 24. I'll go back one so that you can see how, how intense it got there. Um, so then lastly, I'm just going to talk about very briefly about a paper that we published, which again is really taking it to the next level. I mean, because again, there are many people that are measuring air quality. We feel that we are a little bit on the vanguard of this because we have the mobile platforms, etc. And by the way, we use exclusively research grade sensors. I know that there's a lot of interest on low cost sensors, but those are not really very defendable. And so for anything that really needs health or policy applications, we recommend, and I mean, it's been recommended by the EPA, CDC, NIH, etc., that research grade sensors get used. So we looked at the economic costs really of air pollutions. I mean, ranging from things such as um, really job retention. I mean, if you think about someone who's coming in, Utah prides itself on being pretty much a tech hub. So many of the people it attracts for many of the companies have a choice to work really anywhere. So when someone comes in from a place that they know nothing about inversions and they go through an inversion season or a wildfire season, they end up leaving a large amount of them, even faculty members, even collaborators that I've listed there at the end of my last slide, they have actually left because they could not envision raising their family in this type of air pollution. So there are many other economic costs, not just direct health outcomes, but brain drain, really. So I briefly talked about air. There's also water pollution that we work on, sound pollution and light pollution. That's you've seen up here that black logo up there. I'm the director of the minor in dark sky studies, as you heard a little bit earlier. So I do a lot of work with light pollution. And then two other modifiers that I like to call them: food accessibility, looking at food deserts, because again, we eat every day, and what we eat really does shape us at a cellular level. And then temperature, which I briefly talked about. One of the next steps, what we want to do is, like I said, we want to improve our real-time forecasting. I'm working with colleagues who develop artificial intelligence models to really interpolate the data. Again, we're gonna forecast air quality in 1 to 5 days out, because one of the roles that we really want this data to play is uh, outdoor recess guidance. I'm the chair of the asthma task force for the state of Utah, and among the things that I work on are outdoor recess guidance. So it's basically when schools get told try to keep the kids in because the poorer quality day. The problem is that many times that notification happens immediately before recess or even at the beginning of the day, and teachers have not had time to plan lesson plans or really contingencies for keeping kids indoors. So but if we provide a forecast 1 to 5 days out, and that gets passed on to the schools, then that could potentially move the needle a little bit. And then we use historically, and then we're all the data since 2014, we're cleaning it up. We're debiasing some of the data. I'll give you a quick example of a bias. So let's say that one day we're in a really deep inversion, air quality is really bad, but then the tracks, trains, and the buses were primarily in the eastern routes. Well, the tracks just goes across, but let's just say that we had the buses only on east side routes. And then the next day, there's snow or there's rain, the inversion goes, and then the buses just happen to travel on west side routes. Well, an investigator, someone who has no idea, would just look at the data and say, "Oh, look, I'm now finding that the west side has much cleaner air than the east side." So that is some biasing that just happens because, again, we don't control the buses. They can go wherever they are planned on going. So that's something that we're trying to clean up so then we can provide a cleaned up product for anyone to use. And again, we really want to work more towards health applications and policy. So I said, multiple collaborators, contributors is not a one-person show at all. There's been contributions from multiple universities and research groups. And always, I'd like to thank our funders, Salt Lake County, our partners, also Salt Lake City, EPA, Utah Division of Air Quality, Heal Utah, and UTA, of course, for hosting all our sensors and helping us do all this work that we're doing. So happy to take any questions.
You might have to repeat it so they can hear
Yeah,
me.
but go ahead, Don.
On your iPhone, on your weather app, there is an AQI. How accurate is that? And where is that even pulling that data?
So without seeing the app itself, I won't be able to really answer very much. However, what typically happens is it takes an EPA site. So while EPA is federal, the Division of Air Quality is sort of the local agency. And so my suspicion is that it probably pulls the data from Hawthorne, which would be great if you're at Hawthorne, right? Which is 17 South, 700 East. However, as I hope I've shown, there is quite a range of air quality spectrum essentially across the county, depending on where you are. So I would generally say that unless it tells you otherwise, most likely it's going to be one EPA station that is closest to you, if not just a token one that they chose for the specific region.
Anyone else have any other questions for Dr. Mendoza?
I mean, how do we best protect ourselves inside the building during construction?
Good question.
Yeah, that's a really good question. And I think I did see masks in the building. Now, again, here's my concern, because I've also done an addition to my house, and concrete dust is about as small a particle as you can get. So unless you're using something that's really highly rated, say an N95 mask, it might not be as effective. Also, masks need to be worn properly, because it could actually be worse for you to wear a mask improperly. So let me just tell you something that, I didn't really know much about this until obviously COVID. I think that's when we all became somewhat mask experts. But if, for example, you have facial hair like I do, mask would not be that effective, because you actually will be pushing away the mask with your facial hair. That's why everyone who works in and who has to wear a mask for work, they will be clean shaven. The other thing is, you also need to make sure that it does close tightly around your nose, around your mouth, because again, the worst thing that can happen is actually you have a small opening, and then air can go in at a much faster speed. Air just wants to go at the path of least resistance. So if all of a sudden you have a little gap, then what's going to happen is, as you breathe in, air is just going to come in, imagine almost through a straw in a sense. That's what the gap would be. And then the deeper you breathe, the deeper it goes into your lungs. So wearing a mask improperly could potentially be worse than not wearing a mask at all, because if you are not wearing a mask, then you're just breathing in normally, and it might not go as deep because you're not sucking in air as much. I think that ventilation could be done in a different way. I think that the types of filters as well that for the air that is circulating it could be done in a specific way to protect individuals. There, I saw that there's been for a long time now an air purifier. So I would say that being close to it, but of course not everyone can huddle around it, would probably be a good thing. But I think that ultimately this is something that could be discussed with facilities, and really try to understand ways to minimize damage, potentially doing some of the work when there's not a lot of students or a lot of staff and faculty around it as well. But it is difficult. And when I just last went to check on the sensor, I was looking at what's taking place at the School of Medicine. So that's also, to me, somewhat concerning as well, because I mean, both locally, meaning within, 20, 30 yards of it, but also downhill, because all that dust eventually comes down and then settles in other parts of campus as well as the lower parts of Salt Lake City as well. So.
It's Dr. Mendoza. I'm Derek Peterson. I'm your facility manager for both this building and your Winthrop lab. It's good to see that information because the hard part for us for this building, for example, is the way we could mitigate is if we just start sucking outside air in and then blowing the air out so that what dust is created is getting pushed out. But the balance we create is the energy usage. So a lot of those spikes were in July. So we'd be cranking up the cooling and burning a lot of fossil fuels in order to get to that point. So that's usually why we don't compensate too much. But to see it to that degree makes a better argument to say sometimes that's okay. We're going to have 3 or 4 bad days. Maybe it's okay to just crank your full cooling and just look to blow that bad air out.
Yeah, and I'm happy to sit down with you and discuss further because I think that especially as there's going to be more construction, it might be good now that we have evidence that there was substantial concerns back in June, July of last year. I'd be happy to discuss some of this initiatives. I'm working also with the Salt Lake City School District on indoor air quality and potentially also scheduling some ventilation. So I have the same set of sensors over the WBB building, which is again going uphill on 100 South. One of the concerns that we have is during inversions. If you all have, I'm sure you've all driven up that road. There's that stoplight right there, and it's uphill. And so then what happens is during really early morning, 7, 8, pretty much people going to the hospital, cars stop, and then starting a car on flat ground pollutes 20 times more than traveling at a steady speed. Traveling uphill, starting from uphill, probably double, and possibly because many people live close to campus, their car engines are still cold. So that pollution spikes that we see in the early morning, particularly during inversions, are a substantial problem. And one thing that we had been discussing with our facilities team there is seeing if there's a potential to either over ventilate before the rush hour and then under ventilate, not bring in outside air during that time, because I can see very clearly every morning the air that goes in. But the energy consumption is a concern because obviously now you're bringing in very cold air, which then you have to warm up. And then again, we're also concerned about obviously the CO2 levels. So that's there's some trade-offs, and the energy concern is an extremely valid one, especially as we're trying to go towards a green campus, lower emitting, etc. But I think that there are some discussions that we could have in terms of really the trade-offs between health outcomes, because there is a loss of worker productivity, there is a loss of learning ability as well when there are high levels of pollution. So again, happy to chat more, and this data is completely available for you to use however you find it most useful.
So where do heat pumps fit in this? Heat pumps.
So I am not exactly familiar. I have not measured the building with heat pumps at all. So this is that would be, I think, an interesting thing to look at next. So I wouldn't be able to tell you an answer because none of the buildings that I've measured involve heat pumps at all.
I guess for you in this building, we don't have any gas fired boilers. All of our heating and cooling basically comes from the high temp plant that's next to Shoreline, where they do that. So we get either 39-degree water coming in, or we get 180-degree hot water coming in. We switched our water heater to a heat pump about a year ago. Water heater to go a little more electric. But otherwise, we're not creating any emissions in the building for the heating and cooling.
Any final questions for Dr. Mendoza? I know we're over time, so sorry about that. Mendoza, we want to be respectful of everyone's time, but a final question from anyone? Okay. I have one question actually. So for in June and July, we're experiencing the elevated pollutants in the air in real time here in the library. Is there a way for us, is there like a cheap sensor that can just tell us it's way too high? As in just something that would, because we're clearly way over the 50 benchmark. Is there a way that we can just get something pretty simple that in real time, as we're sitting here, I can just look at it and say, we need to be somewhere else today, or encourage everyone to work from home? Yeah, I know your equipment is very expensive, so something simpler that you're aware of.
So one thing that we have, and again, so just to be clear, it's not on June, July. It is just last year's June, July because of the construction. So I want to clear up, it's not all June, July. It's just that past year. So one thing that we have, and here I'm going to share my screen real quick, is all of this data is, hold on, in real time, it's available. Let me pull up one thing real quick here. All right, here, let me just share my screen one last time. So here, can you see this?
Yeah.
Yep.
So this is real time. So if we, for example, if we click on, I don't know, wherever the tracks is at this point, but let's say I click right here, it's at 1:15. We do what's called a snail trail. So we have the last hour for any of these sites. So this one was, 1:24, et cetera, et cetera. So we have all of the last hour and we have all of our sensor data. Now, for privacy reasons, we have not publicly shown your air quality. But if you're interested, so here we've got one, which is an outdoor one. This at Mountain Med, this is Red Butte Garden essentially. So, but those are the sites that we have. But if you are open to the idea of having, your spot would be like right here where my hand is, right? So you'll be like right around here. We could put this on this platform and then you can look at it and, well, the whole world could look at it. And then you could see what it is real time. So if you're ever really concerned, you can look at that. So we have no problems in adding that to our map because we have, like I said, all of the sensors that we operate. And then you can see that we have sensors across Utah as well, and some in Idaho. So and then we have, that's PM 2.5, and here's ozone. So as you can see, obviously now that it's sunny, etc., we have ozone. And so we have sensors everywhere, and we're able to put your specific one. The other thing that we've done is in our building, we also have a touch screen, so just a large TV, and I know you have one right there by the vending machine that has news. We could put that up there. You can just have the website come up, or even just the feed for your building, where it can show this is your air quality, is your ozone, your PM 2.5, and your air quality index, your AQI. So that's easy to do as long as you're open to the data sharing. I know some groups get really kind of antsy and they're not very excited about sharing their data because they're just concerned for whatever reason. But for privacy reasons, by standard, we don't share the data. But if we discuss with the sensor hosts, we can definitely share the data. And you can do that either, like I said, either as an aggregate to here, or if you're more concerned about your, that's more the didactical, right? So everyone can see all the air quality everywhere. Or you can see your own individual one where we just provide you just with your feed. And then you can see, and then, depending on how fancy your touchscreen is, for example, the one that we have there in atmospheric sciences, you press the button and then it can show you the last 24 hours or the last, week or whatnot. So that's interface that we can develop, and we are happy to share that with you. So happy to continue that conversation.
That's promising. Thank you so much, Dr. Mendoza. Okay, well, we will go ahead and conclude. Thank you so much for your time. We really appreciate it. This information is very valuable to our group, and we know that there's many things that we probably now want to pursue moving forward. So thank you again for your time and these resources and information, Dr. Mendoza. It's really valuable to us. Yeah, thank you so much.